What came after the dinosaurs disappeared? 66 million years ago, our planet experienced one of the most important, large-scale, and if you want, sad events in the history of multicellular life forms. Before that, a lot of species were living on planet Earth, according to the rules of nature. But this dramatic event changed everything. Entire classes of species were wiped off the face of the Earth. And we know this because we were able to find hints of their existence. Fossils. But not all of them went extinct. Some of them cleverly changed their appearance, their shape, and transformed their weaknesses into points of strength. They changed beyond all recognition in order to adapt to the new conditions. They were in survival mode, resisting the survival of their entire species. But what happened? The reasons for the dramatic event that led to mass extinction on one side and to the evolution on the other are still not certain. The only thing we know is that the Cretaceous-Paleogene extinction, as it is called, had a huge impact on our planet. From that day on, Earth had never been the same. During the Cretaceous-Paleogene mass extinction, 3/4 of all living organisms died. But perhaps the most impressive thing is that a mass threshold seems to hold. All creatures heavier than 25 kilos ceased to be. At that time, the Earth was populated with dinosaurs, and we all know these creatures were big in size and therefore in mass. 25 kilograms is nothing for a dinosaur. This means that basically all the non-avian dinosaurs got extinct in a short period of time. This tragic event is important because it traces the end of the Mesozoic era and the beginning of the Cenozoic, the era in which you and I are living. The Cenozoic is actually divided into 3 periods, and every period has its own duration, climate, and biosphere. The first one is also the longest one, and it is known as the Paleogene. It spans the interval between 66 million and 23 million years ago. Paleogene is Greek meaning ancient born, and includes the Paleocene epoch, 66 million to 56 million years ago, the Eocene epoch, 56 million to 33.9 million years ago, and the Oligocene epoch, 33.9 million to 23 million years ago. The term Paleogene was devised in Europe to emphasize the similarity of marine fossils found in rocks of the first 3 Cenozoic epochs, as opposed to the latter fossils of the Neogene period, 23 million to 2.6 million years ago, and the Quaternary period, 2.6 million years ago to the present. In North America, the Cenozoic has traditionally been divided only into the Tertiary period, 66 million to 2.6 million years ago, and the Quaternary period. However, the notion that the Tertiary should be replaced by designations Paleogene and Neogene is becoming more widespread. In the first 10 million years of the Paleogene, during the Paleocene epoch, the Earth's biosphere was recovering from the dramatic event we talked about, the same event that caused mass extinction. What scientists know is that due to the great number of dinosaurs and other species that perished, there were lots of vacant ecological niches. Such niches had to be filled again in order to restore some kind of equilibrium on our beautiful but highly damaged planet. Therefore, as soon as they could, they were filled by mammals, the new masters of our planet. If we had a map of that period, we would see that the continents were positioned in a different way than we are used to, although we would still be able to trace them and somehow distinguish them. For example, North and South America were separated by tropical seas, while the Indian and subcontinent was just starting to make for the Asian shores. And of course, the ocean was already there in place. Scientists call it Tethys Ocean. Tethys Ocean was strictly connected to the climate of that epoch. On average, the temperature on Earth was warmer and more stable than today's, and the majority of the planet was covered with dense tropical forests. Towards the end of the Paleocene, the temperature underwent a sudden increase, in geological terms, of about 7 degrees Celsius, known as the Paleocene-Eocene thermal maximum, which lasted for a period of 100,000 years. This high temperature caused an extinction which allows us to distinguish the fauna of the Paleocene from that of the Eocene, the second period of the Cenozoic era. It is believed that the cause of this overheating is the release from marine sediments of 2 million tons of methane cathrates, which cause a greenhouse effect greater than normally attributed to carbon dioxide. The increase in temperature gave rise to a very hot and humid climate, allowing the development of subtropical vegetation up to Greenland in the north and Patagonia in the south, for crocodiles to go as far as the coasts of Greenland, and led to the settlement of primates in the wood plants of northern Wyoming in the USA. As a result, the poles were cool and temperate. North and South America, Europe, and Australia enjoyed a warm and temperate climate. The equatorial areas were temperate, while the areas close to the equatorial line were hot and arid. The overwhelming majority of the living creatures of the day were quite small due to the mass threshold we were talking about. But thanks to the abundance of vegetable food, they soon spread across more and more new areas. We think, for example, that these forests were inhabited by miacids. They are actually considered to be the oldest and most primitive of all carnivores. All the Caniformia families, such as canids, ursids, procyonids, and mustelids, probably derived more or less directly from this family, with a vaguely similar appearance to that of weasels and martens. The size of the miacids was quite small and usually did not exceed 40 centimeters in length. They certainly hunted small prey such as reptiles and tiny mammals. The body was still elongated and the legs were short as in the contemporary Creodonta, but the dental formula had already evolved and their teeth were already similar to those of today's carnivores. The abundant North American fossil material available, like the one in the picture, even if often limited to more or less complete dentitions, allows the distinction of numerous endemic species of the genus Miacids. The next step our planet went through was the Eocene that began 56 million years ago and continued for over 22 million years. During this period, following the collisions between the continents, the current great and beautiful mountain ranges were formed, such as the Cordillera, the Alps, and the Himalayas. The climate reached the thermal maximum of the Paleocene-Eocene, which started this epoch, but also saw the event of the Azola, a small water from whose proliferation caused a global cooling that gave rise to the modern glaciations. The name Eocene, proposed by the English geologist Charles Lyell, comes from the ancient Greek eos, which means dawn, and kainos, which means new, to indicate the new dawn of modern mammals that appeared in this era. If we had a map of the beginning of the Eocene, we would see the Australian continent still united with Antarctica, but beginning to break away from it, as it had already happened to India and New Zealand during the Cretaceous period. The Italian lands that emerged in the Eocene period included Sardinia, Calabria, Puglia, part of the Campania and Lazio, and the current Italian-Austrian border. The most famous Eocene fossils are probably those of Bolca in the Veneto, where more than 160 species of fish, 250 species of plants, crustaceans, insects, reptiles, and birds have been found. Another deposit with exceptional conservation of the Eocene age is that of Messel in Germany, which has provided many remains of vertebrates, including the buxolets and the Diaconexus. Speaking about the climate of this period, we know that it was the most homogeneous of the entire Cenozoic. For example, think about the thermal gradient that we have today between the equator and the poles. It was roughly half of what it is today, and the deep ocean currents were really warm. Also, the polar regions were not the same as today. The temperature at the poles allowed forests to reach high latitudes. If you're still here watching this video, it means you are passionately curious. We constantly strive to make videos that excite a curious person like you. So, be sure to subscribe now and press the bell notification. Even though some species of that time already looked like some we might come across today, others were completely different. An example of one of these is the Andrewsarchus. It was one of the largest mammals that ever existed. Its skull was 83.4 centimeters long and 56 centimeters wide, with a long snout that comprised 60% of the total size of its skull. In fact, its bite is estimated to have been harder than any of today's predators. It is estimated that this animal reached 5 to 6 meters in length. Some research studies show that Andrewsarch's closest relatives were the prehistoric sewer forms of a hippopotamus. The last epoch of the Paleogene era is the so-called Oligocene, and we know it began something like 33.9 million years ago, which makes it roughly 11 million years long. The term Oligocene derives from Greek and means the epoch of a few recent forms, referring to the scarcity of the number of modern animals that originated in that period. In Western Europe, the beginning of the Oligocene was marked by an invasion of the sea, which brought with it new mollusks characteristics of the time. Marine conditions did not exist for long, however, and brackish and freshwater conditions soon prevailed. This cycle of marine transgression, followed by the settlement of brackish and then freshwater environments, was repeated during the Oligocene. The climates of the Oligocene appear to have been temperate, and many regions enjoyed subtropical climatic conditions. During this period, the grasslands expanded and wooded regions diminished, while tropical vegetation flourished along the borders of the Tethys Sea. An important group of Oligocene marine organisms were the foraminiferans, protists similar to amoeba but bearing a complex, often calcareous test or shell. Other marine forms were essentially modern in appearance. Terrestrial invertebrate life was abundant and diverse. The deposits of streams and lakes on the Isle of Wight in England contain the often well-preserved remains of termites and other insects. In the Baltic, many forms of Oligocene insects, including butterflies, bees, ants, and spiders, are preserved in amber. The earliest monkey-like form of Parapathekius is known from Oligocene deposits in Egypt, which also produced remains of several types of Old World monkeys. During the Oligocene, South America was isolated from Central and North America, and a unique mammalian fauna developed there. Surprisingly, many Oligocene South American mammals show extreme parallelism in adapting to forms found in other parts of the world, and with which they are not closely related. The period in the history of our Earth that came next was the Neogene. It began approximately 23 million years ago and ended just 2,508,000 years ago. It is a surprisingly accurate number. Why is that? Because 2,508,000 years ago, our planet started to look almost what it looks like today. The continents finally shifted to their today's positions on the planet's surface, and then if we could go back in time, we would be able to recognize a lot of the animals. I mean, they would at least look familiar to us. Even the Earth's climate, gradually becoming colder, would make us feel at home. During this period, polar caps were gradually growing, and this culminated in global glaciation. At the end of the Neogene, the deep sea dwellers were terrorized by Megalodon, a giant shark measuring 15 meters in length. But then, around 2.5 million years ago, the Quaternary period started, which is the current geologic period. The most amazing and important event that happened during this period is the appearance and evolution of Homo sapiens, as well as its prehistoric ancestors. For example, in the period from 1 million years ago to 100,000 years ago, there lived Gigantopithecus. It was one of the species of great human-like apes known to science, and they were literally giant. Imagine seeing in front of you an ape measuring 3 to 4 meters in height and weighing over 500 kilograms. How would you feel? These creatures lived on the territory of Asia and were related to today's orangutans. Gigantopithecus would not be able to climb trees like other human-like apes on account of their mass, but some of them are known to have dwelled in mountainous areas and made homes in natural grottos, caves, and ravines. These human-like apes had a large brain, which means that they could be relatively intelligent and were probably able to even make primitive working tools. Of course, the population of these amazing giants, as well as others, sharply dropped when the prehistoric ancestors of today's humans emerged and spread across the planet. The Quaternary is often considered the age of humans. Homo erectus appeared in Africa at the start of the period, and as time marched on the hominid line, evolved bigger brains and higher intelligence. The first modern humans evolved in Africa about 190,000 years ago and dispersed to Europe and Asia, and then on to Australia and the Americas. Along the way, the species had altered the composition of life in the seas, on land and in the air, and now scientists believe were causing the planet to warm. The climate was one of the periodic glaciations, with continental glaciers moving as far from the poles as 40 degrees latitude. There was a major extinction of large mammals in northern areas at the end of the Pleistocene epoch. Many forms such as saber-toothed cats, mammoths, mastodons, glyptodonts, etc. became extinct worldwide. Others, including horses, camels, and American cheetahs, became extinct in North America. The last epoch of the Quaternary, the Holocene, saw a new development of human civilization when Homo sapiens spread across the entire planet and dominated all other inhabitants of our Earth. The growth and spread of Homo sapiens completely changed nature's intrinsic balance, and it still does the same in an ever-accelerating fashion. For example, the greenhouse gases that we inject every year into our atmosphere are mostly responsible for the change of equilibrium, and this may globally negatively affect all living things on our Earth, from the simplest bacteria to the elaborate multicellular organisms. Let's be gentle to our planet. Thanks for watching, everyone. Let us know what you think in the comments below, and be sure to watch our other video about dinosaurs through the YouTube cards.